Single element transducer for static ultrasound. Before we go further, let's take a look at part of transducer. There are several components in the transducer. First, piezoelectric material, sensor electrode, isolated layer, backing block, acoustic insulator, insulating cover, and transducer housing. So, for the introduction, what is transducer? For all the diagnostic ultrasound application, the transducer is the heart of the imaging system. Transducer refers to any object that transforms or changes one type of energy into another. The phenomenon that explains this unique transformation is called piezoelectric effect. When voltage is applied across the piezoelectric crystal, the thickness of the crystal either expands or compresses depending on the polarity of the voltage and the molecular configuration of the crystal. They operate by converting electrical energy into acoustic energy to generate ultrasound wave by converting the received pressure wave from echo into electrical signal to be processed into useful diagnostic information. The material used is lead zirconia titanium. The active element is basically a piece of polarized material. It is sandwiched between the electrodes. The piezoelectric element converts electrical signal into mechanical vibration and mechanical vibration into electrical signal. The thickness of the crystal affects the frequency of diagnostic ultrasound. Let me explain in a simple way. When there is no voltage applied across the piezoelectric crystal, the thickness of the crystal is in resting state. When large positive voltage is applied, the crystal is expanded, and when the negative voltage is applied, the thickness is contracted. The rare-phase piezoelectric crystal usually supported by backing material. This component dampens the transducer vibration to create an ultrasound pulse with a short spatial pulse length, which is necessary to preserve detail along the beam axis. To improve sound transmission across the element to tissue boundary, a matching layer is applied. Function is to decrease mismatch between crystal and tissue. The effect is to improve the sensitivity of the transducer while maintaining the very short duration pulse required for good axial resolution. Single element transducer are focused by using a curved piezoelectric element or a curved acoustic lens to reduce the beam profile. Acoustic lens emitted pressure wave from transducer are focused into small region, provided by lens without the need of the endanger of piezoelectric material and apply any mechanical pressure.
Created using Powtoon.